Welcome back to Young Einstein. On our last video, we talked about some examples that you get the sum of the first n terms of GP. So the next thing I want us to get into is sum to infinity of a GP. Sum to infinity of a GP. But before we get into that part of GP, there's a particularly interesting example I want to share with you. Before we get into that example, please make sure you like, subscribe, and leave comments on other topics you'd like to know more about. So get this example. The first, third, and seventh terms of an AP form three consecutive terms of a GP. If the sum of the first two terms of the AP is 6, find the first term and the common difference. Find the first term and the common difference. So let me get this question again. The first, third, and seventh terms of an AP form three consecutive terms of a GP. If the sum of the first two terms of the AP is 6, find the first term and common difference. Now this example is particularly interesting. Why? Because it connects AP and GP. So this question, understand it now. They give us an AP and they mention the first, third, and seventh term. And they said this first, third, and seventh term coincides with the first, second, and third term of a GP. The question actually used the language three consecutive terms of a GP. They don't say whether it's the first, second, and third. It can even be 10th, 11, and 12 as long as the terms are consecutive. That is, the numbers are consecutive. So I'm just, for ease of calculation, like I always say, to ease of calculation, just assume it to be the first, second, and third, three consecutive terms. So they said the first, third, and seventh term of a GP coincides with the first, third, and seventh term of an AP coincides with the first, second, and third term of a GP. So giving just that information, and they said that the sum of the first two terms of the AP is 6. Giving just this information, we're asked to find the first term and the common difference. Now this first term, no need for question on this, like is the first term of the AP. It's also going to be the first term of the GP. Because now the first term of the AP coincides with the first term of the AP. So when you say first term, you know it's talking about, it can be any of the one, whether it's the AP or the GP, first term of the AP or first term of the GP. Now when they say find the common difference you know already, common difference deals with AP. It's just for the GP they will say common ratio, but this is just common difference, so that's AP. So let's get what they're saying now. So for the AP, they are talking about the first term, the third term, and the seventh term. So from what you know, the first term is T1, that's A. So T1 is equal to A. That's for an AP. T3 for an AP is A plus 2D. That's that 3, you reduce it by 1 to get 2. So T3 is equal to A plus 2D. Then T7 will be A plus 6D. T7 will be A plus 6D. Because you're reducing the 7 by 1 to get 6D. So that's what you have for the AP. Now for the GP, the first term is A. So I'm representing for the AP part with capital letter T. Then for the GP part with small letter t. So when I say for the AP T1, I'm using capital letter T1, T2, T3 rather, capital letter T3, T7, capital letter T7. Now for the GP part, I'm using small letter. So T1, that is small letter T1 is A for the GP. Small letter T2 is AR. Small letter T3 is AR is power of 2. That's your GP formula. That's your GP formula. We reduce the 3 by 1 to get 2. Reduce the 2 by 1 to get 1. That's just the GP formula. The T1 is the first term A. Second term T2, that's AR. Third term T3, that's AR raised to the power of 2. So from the question, the capital letter T1, that's the first term of the AP, coincides with the first term of the GP. That's small letter T1. So capital letter T1 is equal to small letter T1. Then capital letter T3, that's the third term of the AP, coincides with the second term of the GP. That's small letter T2. So capital letter T3 is equal to small letter T2. And also the seventh term of the AP, that's capital letter T7, coincides with the third term of the GP, that's small letter T3. So capital letter T7 is equal to small letter T3. So from the first part, that is T1 is equal, capital letter T1 is equal to small letter T1. Capital letter T1 is A, small letter T1 is A, so A is equal to A. That's just it. Is equal to A. Then capital letter T3 is equal to small letter T2. Capital letter T3 is A plus 2D. Capital letter, small letter T2 is AR. So you have A plus 2D is equal to AR. Then capital letter T7 is equal to small letter T3. And capital letter T7 is A plus 6D. And small letter T3 is AR is power of 2. So you have that A plus 6D is equal to AR raised to the power of 2. Now, we'll apply some knowledge of geometric progression in this now. So knowledge of geometric progression. And remember, a geometric progression have what is called common ratio. And your formula for common ratio is you can use T2 divided by T1, or you can use T3 divided by T2. If you don't understand this, please go back to the previous video on the first topic of geometric progression. You understand it better. So R is equal to T2 divided by T1, or T3 divided by T2. And remember, I use a small letter T for geometric progression. So all this T I'm saying are small letters. So you can write it in a fractional form. This T2 divided by T1, you can write it as fraction. That's T2 over T1. The T3 divided by T2, you can also write it as fraction. That's T3 over T2. That's T3 over T2. And remember that T2 is equal to T3. T2 is equal to T3. And T1 is equal to T1. That's small letter T2. Okay, let's do it this way. T2, small letter T2 is AR. Small letter T2 is AR. So this T2 over T1 is AR over A. This T2 over T1 is AR over A. Then on the other side, there is T3 over T2. T3 is AR raised to the power of 2. That is, I'm talking about small letters. T3 is AR raised to the power of 2. Then T2 is AR. So T3 over T2 means AR raised to the power of 2 over AR. Now from what we have, we just got previously, we got that AR is the same thing as A plus 2D. So I'm substituting this A plus 2D for AR. Anywhere I see AR, I will put A plus 2D. So you now have A plus 2D over A. That's T1 is A. T1, that is small T1 is A, is equal to T3, that was AR raised to the power of 2. And we also got AR raised to the power of 2 to be A plus 6D. So you will now have A plus 6D on that side all over A plus 2D, because AR is A plus 2D. So what we have in general is A plus 2D over A is equal to A plus 6D over A plus 2D. That's substitution of what we have gotten. So you cross multiply in this stage. So you have open bracket A plus 2D close bracket, then another bracket A plus 2D close bracket. That's cross multiplication. To be equal to A open bracket A plus 6D. That's on the other side. So we expand both brackets. Let's start from the left hand side. So the first A in the first bracket multiply the A in the second bracket, you get A square. The A in the first bracket will multiply the 2D in the second bracket, you get 2AD. The 2D in the first bracket will multiply the A in the other bracket, you still get another 2AD. And then the 2D in the first bracket multiply a 2D in the other bracket, you get 4D square. Then on the right hand side, the A outside will multiply the A inside, you get A square. The A outside will multiply 6D that is inside, you get 6AD. So back to your left hand side. In the middle part, the two middle terms, that's 2AD plus 2AD. They are common, they are like terms, you can add them up. So 2AD plus 2AD, you can add them, you get 4AD. So on the left hand side, you have A square plus 4AD plus 4D square is equal to A square plus 6AD. So we simply collect like terms. I'm going to leave only D square on the left hand side. Every other term I'm carrying it over to the other side. So 4D square is equal to, on the right hand side, you already have A square plus 6D. Then this other ones I'm carrying over become minus a square minus 4ad. Minus a square minus 4ad. So now what we have 4d square is equal to a square plus 6ad minus a square minus 4ad. So I'll collect like terms together, bring a square and a square together, bring the ads together, that's 6ad and minus 4ad, bring them together. So we have that 4d square is equal to a square minus a square plus 6ad minus 4ad. So a square minus a square will cancel out. So you have 4d square is equal to 6ad minus 4ad. 6ad minus 4ad will be 2ad. So you have that 4d square is equal to 2ad. Now, some terms are common on both sides, on the left hand side and on the right hand side, and those terms are 2 and d. D is common on the right hand side, d is also common on the left hand side. The 2 is also common on the right hand side, and you can also divide the left hand side, that's 4. You can also divide it by 2. So I'm going to divide both sides by 2d, since 2d is common. So dividing the left hand side by 2d, d becomes one of these out, so you're left with only 1d. Then 4 divided by 2 is 2. So on the left hand side you have 2d. Then on the right hand side there is 2ad over 2d. D will cancel d out, 2 will cancel 2 out, so you're left with only a. So what you have now is that 2d is equal to a. You divide both sides by 2. Divide both sides by 2. So you have that d is equal to a over 2. D is equal to a over 2. So you've gotten an expression for your common difference. You have not gotten your common difference because you don't still know a. D is equal to a over 2. You don't know that a. It's just an expression for your common difference. You have not gotten the value of your common difference yet. So this is a good step we have taken. So we are missing out one information in the question. The last information they give us, which says if the sum of the first two terms of the AP is 6. The sum of the first two terms of the AP is 6. So that's why adding the first two terms. That's adding first term plus second term. So first term is T1, second term is T2. We're adding T1 plus T2. So what they say, sum of the first two terms, that's S2 is T1 plus T2, and they said is equal to 6. So S2 is equal to T1 plus T2 equal to 6. Now T1 being the first term, you can just write it as A. T1 is A. Then T2 is A plus D using your your AP formula rather. Your AP formula, T2 is equal to A plus D. So I'm replacing T1 with A, replacing T2 with A plus D. So I have that this T1 plus T2 is equal to 6. Now will become A plus D is equal to 6. A plus A will give you 2A. So 2A plus D is equal to 6. Now we previously got D as A over 2. So that's A over 2, replace it to the D in the present equation we have. That's 2A plus D is equal to 6. So in place of the D, I'll write A over 2 because we just found D as A over 2. So we have 2A plus A over 2 is equal to 6. Now I can find the LCM of both sides. That 2A is over 1, you know. So I'll find the LCM of 1 and 2, which will give you 2. Then how many times can 1 go into? 1 will go into 2 times. 2 times the 2A up will give you 4A. Then on the other side, how many times can 2 go into? It's 1 time. 1 times A is just A. So we have that 4A plus A all over 2 is equal to 6. 4A plus A over 2 is equal to 6. 4A plus A, we will get 5A. So 5A all over 2 is equal to 6. Then you cross multiply, you have that 5A is equal to 6 times 2. So when you simplify it, you have that 5A is equal to 12. Then you divide both sides by 5, you have that A is equal to 12 over 5. That A is equal to 12 over 5. That in decimal, 12 over 5 is 2.4. So A is equal to 2.4. You've gotten your first term. Now you get time to get your common difference. So we can get our common difference using the previous expression we derived for our common difference. That's the part that we got D is equal to A over 2. So you can use that equation to solve for your common difference. So D is equal to A over 2, and we just got A to be 2.4. So instead of writing D is equal to A over 2, we'll have D is equal to 2.4 over 2. 2.4 over 2 will give you 1.2. So D is equal to 1.2. So that is your common difference, and your first term we got it to be 2.4.
you.